not do the stuff in this section? When can I not create a confidence interval?
It's not normal.
When it's not normal. Now, if the population I'm dealing with is not normal, like I just know it's totally not normal, this thing is freaky looking, and I take a sample of 42, is this section worried that the population was crazy abnormal? No, it's like it doesn't care. It's robust. I don't care, right? Because you took a large enough sample, I'm guaranteed by what? Three-word phrase.
Normal enough.
2. I like that. Well, if you carry out the f enough, maybe it's another word. No. Central limit theorem, right? That's the one that says if you have a large enough sample, the larger your sample gets, the more normal your sampling distribution gets. And the magic number for most distributions is 30, right? Now, are they robust against poor sampling methods? Is anything robust against poor sampling methods? If the data you give me to work with comes from a crappy-ass method of getting the data, can I trust anything I do with it? No. Except go, this sucks, right? So if you have really bad sampling method, like you pick all your friends, or you pick everybody you can see, or you make up data, there's no method that could possibly overcome that. I don't care how large of a sample you took, right? 4,500 of your Facebook friends does not create a good sample just because it's big. Yeah.
Okay, I honestly don't understand. Maybe it's because I need to see it. I don't know.
There's nothing I could really show you though.
I don't understand how to answer it though.
All right. Is it able to handle populations that are not normal? Yes, as long as the sample size is big enough.
That's what I said.
Is it able to handle if you select your sample poorly? Is anything able to select a bad sampling method? So if I wanted to say something to all gross plus students and I chose you guys because you're here, because you feel obligated to answer something I ask you, is that a good sample? So any analysis I do with that sample, is it good? Can it be trusted? No. Even though there's more than 30 people in here, right? I don't care. It's a bad sample choice, right? Okay. So that's the thing. Every single section, have you guys noticed? Every section has got something about, well, they picked 4,000 of their friends. She sent out letters to 10,000 people and 2,000 wrote back. They have this kind of, here's a sucky sample. What do you think? It's a sucky sample. Ain't going to work. They want to really hammer that home. Any other questions from homework? All right. You guys are all like, it's Tuesday and the week of Thanksgiving sucks, man. It's a whole week off. I'm sitting in the stats class.
Hey, we didn't say it.
No, I can feel it. It's emanating. Get enough people together, I can read it. It's like, all right, so I can't promise you that this is going to be painless, so too bad. No, it's not going to be painful. I want to do just obviously follow up with what we did last week with just more examples, and we have to get into the other sections. Section 8.4 versus Section 8.5, they're really the exact same thing. Can you guys tell me if I have a sample of 87, but I don't know the population standard deviation, what do I have to use?
T-scores.
T-score. And that's just that easier to use chart. It's even better. Sweet. So Section 8.4 is when I'm allowed to use Z-scores, and Section 8.5 is when I can't, when I have to use T-scores. So I really hope you guys realize 8.4 and 8.5, same thing. The only new thing you'll see in 8.5, this would remind me, and I said this last time, what do you do when they give you a list of data and they don't give you anything else? They say, here's a claim about this list of data, test it at 0.01. What do you do? What do you need to have before you can make a z-score?
Calculate the standard deviation.
Yeah, I need the mean, standard deviation. How do you do that when you have a list of data?
Put it in your list. Do one variable stat.
Okay, cool. You put it into your list. Do one var stats. So we'll do one like that today. Right? We'll try to do one like that today. Okay. In fact, let's start there. Let's do one like that right now. So let's see, page 427. It's actually going to be page... let's see, 429. Number 26. So take a look at that one. Let me help those of you who are not bookful today. So you guys see that one's about the number of English words. It'll come up eventually. So simple random sample of pages from Merriam-Webster's Collegiate Dictionary is obtained. Listed below the number of words defined on those pages. Given that this dictionary has 1,459 pages, the claim that there are more than 70,000 defined words is the same. Blah, blah, blah. So we're testing the claim that the mean number of defined words on a page is greater than 48. Now again, I actually hate this book's homework problems because they are definitely far away from interesting, right? Why the hell would I care how many freaking words they define on a page in the freaking dictionary? But I hope you guys realize, and I always try to make my test ones a little bit more interesting, statistics can be used on all kinds of situations, not just words in the dictionary. Okay, cool. So you have to kind of read through a lot of this business, and some of this stuff has nothing to do with us. They just try to explain why the claim is what it is. So somebody help me out. The steps we go through, the very first thing we have to do is what?
Place to stay there for calculator.
Not yet. What's the very first thing I have to do?
The claim.
Alternate hypothesis.
Input the information. Okay, I like this. I hear some things about hypothesis. Before I can even do the hypothesis, though, I need to know what the...
Claim.
So what is the claim in Mathish? Yeah, so they test the claim that the mean number of defined words is greater than 48. So we're going to test the claim that the mean is bigger than 48. So which one is that going to be? Is that going to be...
That's HA, the alternate hypothesis.
The book I used to use used to call it HA. So
H1.
sometimes I write that one. Yeah, H1. Why is that one H1?
No, it claims this from sample. Because you have to prove it.
No equal sign. No equal
There's no equal sign. In a sense, you're right over there. But the more immediate way to tell us there's no equal sign. It's actually the statement that I can show evidence for or not. Right? It's going to be greater than, so it defines the tail. There's no equal sign, so I know it's H1. So what's HO going to have to be? Less than or equal to. The exact opposite of this guy. Okay. All right. Yes, sir.
Would that be a big difference for you if we just put equal sign on top instead of less?
Some books do
You're
that.
saying that some books.
Some books do that, but what that doesn't allow for is if my claim was it's at most 48, I'd want to be able to write it like this. Some books actually say HO is always equal to. I disagree with that. Does it really change any of the work we do or the conclusion we come out to? No. So if you want to put an equal sign there, that would bother me because it's accepted. But it just makes more sense to me for these to be opposites. Right, here's one claim, here's the opposite claim. If this is not true, then it seems like that might be true. It's opposite, yeah. How many tail tests will this be?
One.
On which side?
On the right side.
Good, because it's greater than, right? One tail. Up here.
And how do you determine that?
Hmm?
How do you determine that? If it's one tail.
What's going to show evidence for H1 to be true or not? What's going to make it support this guy? So the rejection region is always set up by this guy. So I want to show that the mean is actually bigger than 48. So I want my sample to show up there. Right? And the nice thing is, the quick thing is that points you in the direction of your rejection region. Right? I actually have a handout that hopefully I have enough copies of because my copier was creeping out. But that we'll do today that actually has a claim that's a two-tail test, because I don't think we've done a two-tail test yet. So step 2, can I use Z, T, or nothing? So what do you look at to determine that? All right. And what's kind of missing here that really isn't? What do you have to know to be able to use Z or T? What's got to be true for either one? It's got to be normal. And the sample's damn small, isn't it? So you might think, well, I can't do this. Nah, not Jeff. Nah. But then you look back at your blue. Let's go put this back up there. Look back at your blue thing on the page before. Assume that a simple random sample has been selected from a normally distributed population. So if the population is already normal, does my sample have to be 30 to make it normal? It's already freaking normal. I can pick a sample of 2, and it'd be great, right? So I know it's normal. That's number 1. I know it's normally distributed. I have to have that to be able to do anything. And now, do I use Z or T? Why?
We don't have standard deviation.
Because they don't have what standard deviation?
Population standard.
Normal. Check. 2. Sigma unknown. T-score. Why were T-scores invented? To cover our ass for when we don't know sigma. There you go. That's why they were created. To help us for when we don't know sigma, we only know S. Okay, let me see. Try this guy out. Now I try to set up what? What do I do in the third step? Rejection region. I want to see what's far enough away. Set up what my benchmark is, and then the next step would be, did I get there or not? Right? So step 3 is rejection region. So what do I use to determine that? Well, we just said we have to have T-scores, right? So I definitely need alpha. Alpha tells me the area in the tail. So what's alpha in this case?
5 or 0.05.
Yeah, they say use a 0.05 significance level. And that's another name for alpha, is the level of significance. So alpha is 0.05. What else do I need to be able to look up the T-score? Degrees of freedom. Cool. And that comes from what? N minus 1, 11. And what is N? So degrees of freedom is 10 minus 1 is 9.
In our chart, are we looking at one tail or two tail? One.
And we know it's a one-tail test. So can you guys look up that T-score?
1.833.
How do you know there's 10 and everything?
Just counting the list on this. Yeah, that's my sample, right? So I can just count them. So degrees of freedom is 9. I got a one-tail test where alpha is 0.05. So look to where those intersect, and I get, looks like 1.833. Is that cool? Okay, maybe not. So again, one tail, two tail? No, it's one tail. Alpha's 0.05. Go down and stop at your degrees of freedom, because I don't want a z-score, I want a t-score. So I got to stop at the degrees of freedom, 1.833. If it was a z-score, I would be using 1.645. Right? I go all the way to the bottom. So what is it that makes sense about this? Should it be harder or easier to pass the test if there's something about the problem I don't know? Harder, right? It should be more difficult to pass the test. If I don't know the standard deviation, shit, you better show me some damn good evidence then if you're saying, I'm not really sure about the standard deviation. So that's why this is bigger. This is the score I have to get to. My sample has to be bigger than this, further away than the mean than this. Not this now. That would have been easier. Damn, I got to do this. Okay. Go back to it. Okay, cool. So what did I just say? 1.833? Okay, cool. So then my rejection region, we already know it's going to be up here. 1.833 positive because it's over that way. Now the test, I don't want to give anything away, so don't necessarily call it T star or Z star. You know, I might say calculate Z or T star just to cover my head. But very often I'll just say calculate Z star. You'll be like, well, I'm using T star. Who cares? It's the same formula that you use. It's the same thing. Z and T are basically the same idea. So don't complain about if I use Z or T. They're basically the same idea. But in this case, if you want to be a little more specific, you can say if T star is where, then what? If I find my sample, and it's how far away at least, what can I say? Careful.
Or
1.833.
If it's greater than 1.833 standard deviations away,
Reject
reject
the
the hope, support the high. Because again, it's not enough just to get more than 48. If I get 49, is that good enough evidence? I don't know if it's far enough away. Because don't ever forget this. We're taking a sample to get that number. So what's built into this whole thing is it understands it's only a sample. In order for a sample to show evidence, you got to have that sample be really far away. Because it's just a sample. The bigger the sample, the easier it's going to be up there, but it still has to be this far away or more. Right? So if the thing I find for my sample is more than this, if it gets in here, I reject the O or support the I. It's a good reason for calling that the rejection region. If I get in there, I reject the HO. All right, so we defined what far enough away is. We set the benchmark. Now I go take a look at my sample. So this is where I want to remind you guys how to do this. It's been a little while since we did this last. Remember what I said about chapter 3. Am I ever going to make you do those standard deviation tables ever again? No, so don't do them. I appreciate the work, but there's no need for it. So now how do I do this then? They give me this list of data here. To get the mean and the standard deviation, where do I put those?
Stat.
I like it. Go to stat. Edit. Cool. Then clear out whatever's in there and put this data in there. And of course, it's way over here now. So put the data in there. Let's see the data. 51. 36. 43. 44. 62. Sweet. All right. Thank God. Make sure you end up on 10. You have 10 data points. So I know it's frustrating when you put something in there wrong. I mean, they made this emulator a little too good. Sometimes my keys stick in this program, and I put, instead of 62, I put 6. That's going to totally throw off your whole results, right? But I'll kind of know to look for that. I understand that it's frustrating. Just be careful when you put your data in. So obviously I'm not going to give you a list of 88 things. I mean, that's slightly evil. Except maybe on this take-home test. Which I will do. Oh, that's too bad. I thought it was funny. Now, where do I go to actually calculate stuff about this data?
Go back to stat.
Go back to stat?
Calculate.
Calc. I love it. One var stats, one variable statistics, right? We still only have one variable, the number of words on the page. So enter. It defaults to list 1, and that's where I put it. Sweet. Enter. So now in step 4, I can summarize my sample data. Bless you. We get X bar is 53.3. Which standard deviation do I put down?
S.
Beautiful, because I know it's not a population. The calculator doesn't know. It gives me both. I know it's a sample, so I better use the S. Now before I calculate my z-score, or my t-score if you want to be specific, what do I have to do? Always. Before I do my formula, what do I have to do? Change my standard deviation. This freaks people out. When I do this, I am not making a sample standard deviation. I'm not. I'm making the standard deviation for groups of size n. This standard deviation, in fact, I love the calculator does this. You see how the calculator puts a little SX? Right? So this is the standard deviation good for individual data values. I need the standard deviation good for groups of size, I forget now, 10. So I still need to do this, I just need to do it with S. This S is still just good for individuals. I need the standard deviation that's good for groups, because that's what I have. I have a group. So I still have to do it. So take the old one, divide by square root of 10. Cool. All right, so I get 4.951, rounding it up. How are we doing? Does that make sense? I mean, that's, people seem to not understand that you're not, when you do that formula, you're not making S. You're making the new standard deviation for groups. Same thing, this is just my estimate for sigma. I don't know what it is. I'm going to use the one I saw from the sample. I still have to convert it to the one that's good for groups. I still have to. So then, it's not a whole new formula. That's why I try not to make a big deal out of this. A t-score formula is the same damn formula as a z-score formula. It just has an S in it instead of a sigma. It's the same formula, right? So it's still going to be my data minus the mean that I see in the hypothesis divided by the standard deviation that I just got. Same formula. So what did we get from my data was 53.3. I want to see how far it is away from the claim over there, the 48, divided by the new standard deviation. Here's a real silly question. If this would have come out to be 46, what would you do? What's the claim?
48
What about 48?
is greater than.
Greater than. So if I got 46, what would I do? I'd stop and go, damn, maybe I'm wrong. You guys get the, I mean, if the claim is great, and this is why I'm saying this, there is a problem in somewhere in this chapter, I can't remember where they do that. The claim is it's bigger than 7, and you get 2. And you're like, and then everybody kind of does the work. And no, stop right there. Obviously, the claim is wrong. Your mean is smaller than what your claim was supposed to be saying. Then there's no way it could possibly be true, right? It doesn't happen that often yet.
So how would you write a conclusion?
For that one,
Yeah.
you'd say, from my sample data, the claim is not supported, right? Officially for you guys, you can just say this problem can't be done with a sample because it doesn't fall where I want it to fall, right? Okay. What are you guys getting for this t-score?
1.0705.
1.0705?
What?
I like the specificity.
Would you?
I mean, I just like the word specificity. Divided by 4.951. Just make sure everybody sees how to put this in there. I still see people making the mistake of not putting the parentheses on the top. You've got to tell this poor little calculator what the top is. It doesn't have eyeballs, so it's not as advantaged as we are. You got to put parentheses around the top. Cool. Which means what then?
You can't reject the null hypothesis.
That fell right about here. So did we succeed or no?
No.
We failed. Big time. So fail to reject HO. Fail to support H1. Remind me, which one was the claim? HO or H1? H1, right? So I know I'm going to word my next step. I'm going to use these words to write the conclusion, right? Right there. I know I use those words because I want to write the conclusion based on the claim. And the claim is H1. If the claim was HO, I'd use these words. So how does the conclusion start off then? We have, careful, we have not, because we failed, right? We have not found. Not found sufficient evidence. To do what?
To reject the null hypothesis.
True, but more specifically, I always want to word my conclusion based on my claim. My claim was H1, so I want to use this kind of language. We have not found sufficient evidence to support the claim that
The average word count per page is greater than 48.
good. The average number of defined words greater than 48. Cool. Always word your conclusion with something from the actual problem. What physically is going on? Don't just say, we have not found sufficient evidence to support H1. Tell me what the hell H1 is. And you can just take it right from the question in the book. Just rewrite what they say. Okay. How are we doing there so far? I mean, that's a little review. If you weren't here last time, you're like, damn, why did I have to miss last time? Because what the hell's going on? All right. So now I want to do one that I actually have a handout for, which unfortunately, let me see how I can work this out.
You did it to repeat.
What's that?
You did it to repeat.
Oh, P?
P-values.
For T-scores, it's really difficult. Do they ask you to do that here? Yeah. All right. For T-score is not the easiest because look at the chart here. This chart is easy to find p-values because the p-values are these. Oh, that's good, Jeff. That's useful. I like the way you guys are just sitting there. Please realize what you're doing, Jeff. That's even better. Okay. So for z-scores, the p-values are all these, right? The p-values are just the areas and the tails. The T-chart is easy, but one reason it's easy is because it's smaller, it has a lot less information in it, right? So it's very difficult to find p-values here. To find a p-value from this chart, what was our t-score? It's always related to the score we get from our sample. What score did we get from our sample?
1.3.
Careful. From our sample, we got a score of 1.07, right? You guys with me? 1.833 was the benchmark t-score from the alpha. What was our t-score? 1.07. Degrees of freedom was 9. What's the closest to 1.07 here? Do you see any 1.07s in here? No, right? So the p-value is going to be greater than, and this is a one-tail test, right? So greater than 0.10. If the t-score we had gotten, just to give you another example, if the t-score we would have gotten would have been 2.6, where's 2.6? For degrees of freedom of 9, where's 2.6? In between these two, right? So the p-value would have been in between this and this. Because aren't these the areas that go along with the scores? Here, this is beautiful. How many areas do they give me? Tons of areas. I can find a specific area. Awesome. Here, where are the areas? Only these. Oh shit. That's why in the instructions you'll see they say give a range of p-values. Because that's the best I can do is give a range. For us, we were way off the chart here, right? So we're greater than 0.10. Right, doesn't our score 1.07? Doesn't it have a big old tail?
Yes.
So it makes sense. It's going to be bigger than 10% tail. It's way bigger than this guy, and this guy was 5%. So our tail is bigger than 10%. That kind of makes sense. So the best I could do for a t-score, I'm not really going to ask you to do t-score p-value because they get a little freaky. The best you could do is give a range. Okay. So let me give you guys this here. And let me see if I have enough copies. Just look at the blank side, all right? For right now. Sure. If any of you guys, you're keeping up on the Occupy Wall Street stuff? Do you know about the Occupy Wall Street stuff?
Yes.
Do you know that we have Occupy San Diego?
Yes.
We have Occupy fill in the blank, basically, right now. They had a story on the news the other day about Occupy Memphis and how it's getting a lot of trouble. But certain cities wouldn't take as kindly to this movement as other cities might.
Oakland.
Oakland is a good example. Of course, Oakland doesn't take kindly to much anything. Sorry if you're from Oakland, but it's true. Anytime.
Have you seen the one in Seattle?
Seattle, yeah.
It's crazy.
There's something going on there. Seattle always does.
I mean, Davis is the worst.
Of course, Davis just had the pepper spraying incident. Let me get some. I got some blank.
I have an extra one.
Oh, sweet. Thanks. Separate sheet there. Cool. Thank God. Okay. So this is from section 8.3. 8.4 and 8.5 are both tests about means. So you're going to see X bar and mu. 8.3 is tests about proportions, percentages. So you're going to see P hats and Q hats and stuff like that. So let's see if we can start this problem off here. Actually, I'll tell you what, this might be better up here. Let's do it here. We'll do it live. Okay. All right. Real quick, somebody remind me, before we get into this, remember here's the confidence interval for mean, right? You're like, why the hell is he going back to that? What was the confidence interval for percentage? What was here? P hat, good. Plus or minus z square root.
P hat times Q hat.
I like it. So this effectively was what?
Error.
The error.
This is the error. This is effectively standard deviation. I like it, right? So where do you think this is going to show up if I have to make a z-score for a percentage? My z-score for this is my data minus the population data divided by, basically this here, right? We normally do that on the side. My z-score for a percentage is going to be my data. What's my percentage always going to look like that I get from a sample? Not just p. P hat, right? The little hat tells you it came from a sample. Minus the population percentage divided by its standard deviation, which we now know is that. We've known that since we did confidence intervals. I hope you guys you can see the direct analogy between these two. So this effectively acts like this guy's standard deviation, just like this is this guy's standard deviation, right? Same idea. Notice how here I don't have little hats on these dudes, right? Because in hypothesis tests, I do know this, don't I? That's given to me in the claims. So I don't have to use little hat dudes. I'd much rather use what I know, the P and the Q, the population P and Q. The biggest mistake to make on these problems is to put the P hat and Q hat in here. And that will throw off your z-score sometimes. So let's get into the nitty gritty. I'll show you when we get to that step where to be careful about it.
It's section 8.4.
This is section, this is going to be section 8.3. We're finally coming back and finishing out the first parts of chapter 8. Okay. So looking through this problem, oh good, I can do it up here. What would you say is the claim?
20% of Americans are opposed.
Yeah, so in English, we feel that 20% of Americans oppose, right? The Occupy Wall Street. How would I write that in Mathish?
Equals 0.2.
In this case, I'm not using the mu, am I? Because this is a test about a percentage. So I'm going to say the P equals 0.2. Cool.
Why using B? Why using B?
Though the reason I used mu before was because it was a test about a mean. And mu is the population mean symbol. This is a test about a percentage. Therefore, I want to use the population percentage symbol here, right? My claim can't be about a mean if I'm talking about percentages. So which one is that, HO or H1?
H1.
HO always has to have the equal sign, and this has got a freaking equal sign in it, right? You can't go wrong with that. So it's got to be HO. So it's H1.
It's not.
Not equal to. I love it. It's got to be the exact opposite. So this is the one time it's not equal to. So how many tail test is this finally? Two tail test. I love it. Two tail test. Like that. Whoa.
Explain real quick what is two-tail.
If the now here's the one you can really tell easily. If the claim is we feel it isn't this, we feel it's different from 70% or something like that, that's an obvious two-tailed test. Because how do you show something's different from something? To be different, it can be bigger or less. That's why it's two tails. This is really the same thing because the claim is we feel it is this. And that's the hardest one when you're doing these problems. If you're having trouble telling if it's a one or two tail test, it's probably two. Because it's really easy with one. What kind of words do you see with one? We feel it's greater. We feel it's increased. We feel it's less than this. We feel it's lower than that. There's these directional words in it, right? For this, there's none of that crap. We feel that 20%. We feel that it is 20%, equals 20%, which means the opposite is not equals. Like we said earlier, that is a two-tailed test. Not equal to, you can show bigger or less. You guys look very excited. So, now here's the key question. How can I tell what's the first thing I always want to show for any of these hypothesis tests to know what I can use?
Is it normal?
Is it normal? And how do I tell it's normal? What do I have to check? For an NPQ problem, what do I check to see if it's normal?
Greater than
Careful, no.
NP
NP and NQ have to be bigger than 5. So NP, NQ. What's N? Well, don't tell me on the answer key I actually did it wrong. Yeah, I think I did. 996. I'm worried on the answer key. I think I had 189. Too bad for me. 996 times, and what's P? 0.2. I love it. P is 0.2. And Q would be 996 times 0.8. All right, so whatever the hell that is. Well, 99.2.
Yep.
Which means this will be 796.8.
Yes.
So is that good enough?
Yes, sir.
Okay. So quick word. on the answer key. Some of you guys have the answer key in the back for this problem. You'll notice I put a 189 there like an idiot. So it should be 996. In my defense, I was doing this about 5 minutes before class started. So. I'll tell you this really cool little thing. And very often I'll word it on a test to show this. You never use t-scores on an NPQ problem. Here's why. Do they have to tell me any standard deviation in the problem?
No.
No, so I always know sigma, because I'm going to build it based on P and Q, right? I always know my standard deviation of my population, because I'm going to build it myself. So it's either normal and I use z-scores, or it's not normal and I do nothing. That's awesome. So you never use t-scores with a percentage problem. It's either normal, because NP and NQ are bigger than 5, so you use z-scores, or it's not normal and you do nothing. That's awesome. Sweet. So here's the first thing that really changed, and it's really related to n greater than 30. It's just what the corresponding test for percentages. Part C doesn't really change at all. It's a two-tailed test, right? What's alpha?
0.02.
0.02, cool. 0.02 level of significance, so that's alpha. So what are my z-scores going to be? So you can look in your T chart, remember? Yeah, so look at my T chart. Two-tailed test, 0.05. All the way, oh, not sorry, 0.05. 0.02. All the way down, 2326. I like it. Bless you.
Where
Yeah.
did you look that up at? On the z-score?
On the T chart, tell you honestly. And this is where students always look at me like I'm crazy. But who can remind me what is beautiful about the bottom of the T chart? What lives down there? Z-scores live down there. Kicks ass, because this is beautifully set up for hypothesis tests, right? There's one tail hypothesis test, two tail hypothesis tests with all kind of different alphas. If I need a z-score, I just look all the way at the bottom. I don't stop, that's a t-score. I go all the way, that's a z-score. Sweet. Okay. So how do I say this in English?
Z star equals 2.326.
Greater than 2.326, or z star is less than negative 2326, we can do what? I feel like Ben Stiller from Ferris Bueller. Anyone? We reject the hoe, right? Because if we get into the rejection region, we can reject it. That makes sense. Which also means if we say he's wrong, we can say the other guy looks to be right. We can support him. The H1.
So we're always rejecting H0 and supporting H1?
That's right, if we get in there. If we don't get in there, we fail on both of those counts, right? Because we didn't get far enough away. But if we get in there, if we get in here or there, we reject the hoe, we support the high. Notice something, the hoe has always got the equal sign in it, right? So it's always supporting that it's actually here in the middle. It's always saying it's equal to the thing that they think it is. And if I find something that's so far away, that's why I can always reject the hoe here. I can say, no, it can't be that. It's so far away from the middle, it can't be that. So here's our brand new z-score formula here that we talked about earlier, right? So now I just have to kind of summarize what I know from my sample and figure out what the z-score is going to be. So what's my n for my sample? No, it really was. Oh, well, I might have put the wrong number there.
No, you put
Going so
996.
cool. I did think that. So 996. What's my x? Beautiful. Remember, x is the number of successes. So I had 189 people say they oppose it. I'm not saying it's a success because I oppose it. I'm just saying it's a success because that's what I'm looking for, right? And then what's p hat going to be?
0.18.
I like it. So you divide these two. Rounding to 3 places, it actually does come out to be 0.190, so just 0.19. You get like 0.1897, whatever. So I can just make that 0.19. Well, you guys try to do this formula. Fill that in. Don't forget that we know what P is. So therefore we know what Q is. me make sure everybody's on the right track. So our data point is the 19%. What's P?
0.2.
0.2, I love it. The thing I see from the hypothesis test, right? 0.2. Divided by square root of, now what's P again?
20.
20, good, not 19. So P is 0.2, what's Q then? 0.8 divided by N, which is 996. Now do you see where I put the parentheses? This is exactly how you want to put it into your calculator, just like this. Don't close this parenthesis until you're out. Of course, again, those of you with the newer TI-84s, your bar extends for you, right? Ooh, no, I'm sorry. I'm a little jealous. So what do you guys get for that? Negative 0.79 rounds up to?
Yeah.
So make sure you can get that. Let me know if you don't. Okay. Those of you who want to attempt it now. Real quick, I of course, forgot to get the p-value on the answer key. How do I get the p-value always? It's the area that's where?
Underneath negative 0.7.
I love it. The area in the tail that my score makes. So if I just look up negative 0.79, negative 0.79 looks to be 0.2148. And that's the p-value because, of course, the z-score chart gives me the area below, which is exactly what I want. So my p-value there is 0.2148, which the more you know statistics, and of course we're all beginners in this class, well, thankfully not me, or else that would be trouble. But the more you know statistics, the more that kind of p-value just jumps out and you goes, crap, he didn't show anything. That's not evidence of a damn thing. The smaller the p-value is, the more evidence it is for something. Because that would mean the smaller your tail, the further away from the middle you are. Because how far did we get away? Negative 0.79? We barely got anything away. We didn't get a whole step away. Right? Yes?
Sorry, can you repeat real quick the p-value again?
So our score is negative 0.79.
Okay.
The p-value is the area in the tail that your score makes. So if you just look up negative 0.79, you'll get the 0.2148. Cool. So there's a good 21.5% in that tail. Holy crap, that's a huge area, right? So do we reject it or fail to reject the whole? We totally failed, right? We did not get into that rejection region. We didn't get out there. We got here. So right here I can say fail to reject HO, which means I fail to support H1. Thankfully, I think I wrote it a little better on the key. Now is when you go back and you see what your claim was. Which one was our claim, the HO or the H1? Yeah, the HO was our claim. So I want to use this wording when I go to write my conclusion. I want to write about my claim. My claim was HO. I better use these words. So how would I say this? We failed, so we have not found sufficient evidence to reject the claim that. Do you guys see everybody has so much trouble on when do I say reject, when do I say support? If the claim is HO, you use these words. If the claim is H1, you use these words. Nothing more to it. In this case, the claim was HO, so I want to use these words here. So we have not found sufficient evidence to reject the claim that what? 20% of Americans oppose OWS. Cool. And for those of you lucky enough to have on the back an answer key that is legible, my printer had plenty of ink, but it kept complaining for more, so I just did what I could. Hopefully you see that's basically what I got there. So do you see how even when we're doing percentages, I have a different formula here, right? I have a different test to know if it's normal or not there, but it's really the exact same steps. The steps are the same. So let me give you one to try on your own so I can run and get your take-home quiz, which is now not due until Tuesday, all right? So you can do it in between helpings of whatever. Let's do one out of the book here, page. Let's do one of these percentage ones. Let's see. I like that. Yeah, let's try number 9.
What page?
What page?
Okay.
Page 409. Free zone. All right, I'll be right back. while you guys are finishing it up, I'm going to first pass out a handout that's actually about chapter 10. I'm going to push the test back. I can't remember if I said this last time or not. The test won't be a week from today. It'll be that following Tuesday. Right. So the very last Thursday of this year, before finals week, will be dedicated to review for the final. Okay? So this is a little handout about chapter 10. You can look at it or not. Just make sure you bring it back with you next Tuesday. Hopefully some of you guys actually look at it. And then we'll get into chapter 10 next time. And I'll have a practice test for you next time.